myself B. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today our topic is problem solving on Charpit's method. Already we discussed in the previous class theory of the Charpit's method. Today we will discuss the problems on that Charpit's method. Okay, what is the procedure for the Charpit's method? Charpit's method means, first we will discuss about that question here. Using Charpit's method to find the complete integral of z square is equal to pqxy. What's the first question? Using Charpit's method to find the complete integral of z square is equal to pqxy. From the procedure of the Charpit's method, first step, what is the first step? From the given question, let us assign that as one function. Okay, that is f of xyz. Okay, pq is equal to what? pqxy minus z square is equal to 0. This is the first step from the Charpit's method. From the given question, I will assign that as with respect to f, that is f of xyz pq is equal to pqxy minus z square is equal to 0. And what about the second step from the Charpit's method? Okay, assign auxiliary equation. Okay, from that auxiliary equation, first I'll find out the differentiation of f with respect to x, y, z, p and q. Okay, that means here for the function f, let us assign that as the first equation. From that, differentiation with respect to x as that as dou f by dou x. Dou f by dou x is equal to dou by dou x of pqxy minus z square. With respect to x means here pqy as constant and x differentiation as 1. And with respect to x, z square as 0. Therefore, what is dou f by dou x? That as pqy. That is first one with respect to x, f differentiation as pqy. And the second differentiation, f with respect to y. Okay, that is with respect to y means here, okay, pqx as constant, then y differentiation as 1 and z square differentiation as 0. That means dou f by dou y is equal to what? pqx. Dou f by dou y is equal to what? pqx. And the third one, f is differentiation with respect to z. Okay, with respect to z means that the function differentiation is with respect to z, pqxy as 0 and z square integration is minus 2z. That is here minus 2z. Next, differentiation with respect to p. Same function, differentiation with respect to p. That is here with respect to p as qxy is constant. Qxy is constant. That is p differentiation as 1. That is qxy. That's the differentiation with respect to p. And next, differentiation with respect to q. With respect to q here, pxy as constant and q differentiation as 1. That is dou f by dou q is equal to what? pxy. Okay, therefore dou f by dou x pqy and with respect to y differentiation is pqx, f with respect to z differentiation as minus 2z and f differentiation with respect to p as qxy and f with respect to q differentiation as pxy. Therefore, now substitute each and every value in that auxiliary equation. What is the auxiliary equation form here? dp by dou f by dou x plus p into dou f by dou z. That is equal to here dq by dou f by dou y plus q into dou f by dou z. That is equal to dz by minus p into dou f by dou p minus q into dou f by dou q. That is equal to what? dx by minus dou f by dou p, that is equal to dy by minus dou f by dou q. Now substitute, this is the auxiliary equation from the Charpit's method. Now substitute each and every value in the Charpit's auxiliary equation. That is or that Charpit equation, write it as dx by minus dou f by dou p form, that is equal to dy by minus dou f by dou q form, and dp, dq and dz. Write it as like this also, or dx, dy, dz, dp, dq. Okay. Now I'll substitute here dx by minus dou f by dou p. That is dx by what is dou f by dou p? That is qxy. But in the formula here minus is there. That's why here we got minus qxy. This is equal to dy by minus dou f by dou q. What is dou f by dou q here? Pxy. Then substitute here, that is minus pxy, and that is equal to dz by here. What is the formula of dz by here? Minus p into dou f by dou p. Okay, I'll calculate here that one. dz by formula minus p into dou f by dou p minus q into dou f by dou q. That is dz by minus p into what is dou f by dou p here? That is qxy minus q into dou f by dou q as pxy. This is dz by, okay, minus pqxy minus pqxy. This is this. After substituting that, we got minus of pqxy minus pqxy. Next, that is equal to what? dp. dp by dou f by dou x plus p into dou f by dou z. Now substitute here. That is dp by dou f by dou x plus p into dou f by dou z. Now substitute here dp by what is dou f by dou x here? pqy plus p into what is dou f by dou z? That is minus 2z. This is equal to dp by pqy minus 2pz. That is dp by pqy minus 2pz or 2zp. Next, that is equal to what? dq by. What is the formula of dq here? dq by dou f by dou y plus q into dou f by dou z. I'll substitute here, that is dq by dou f by dou y plus q into dou f by dou z. That is dq by what is dou f by dou y here? pqx, and dq by, okay, plus q into what is dou f by dou z? That is minus 2z. Therefore, what is dq? dq by pqx minus 2zq. Okay, after substituting all values in the auxiliary equation, we get like this. That is dx by minus qxy, that is equal to dy by minus pxy, and dz by minus pqxy minus pqxy, that is minus 2pqxy. That is equal to dp by, here what is common? P is common. That's why I'll take p is common. That is p into qy minus 2z. That is equal to here dq by, here what is common? Q is common. Then I'll take q as outside and the remaining as px minus 2z. This is the auxiliary equation. From the auxiliary equation, okay, I'll take, okay. Now from the auxiliary equation of either we got p value or q value. Okay. Then I'll take here from the auxiliary equation dp by p minus dq by q form. That is equal to dy by y minus dx by x. Okay, this is the possibility to take, okay, to solve either p or q value. That's why I'll take the auxiliary equation dp divided by with the p and dq is divided by with the q, and the two are subtracting, and that is equal to dy is dividing with y and dx is dividing with x and subtracting the two. That is equating with this one. That is dp by p minus dq by q is equal to dy by y minus dx by x. From that is dp by p minus dq by q by, okay, after multiplying with the p here, dp divided by p means here p is cancelled. That is, we got qy minus 2z. From that, if we are dividing with the q, that is, here q is cancelled. We got minus px plus 2z. Therefore, dp by p minus dq by q divided by qy minus 2z minus px plus 2z. That is equal to RHS side dy is divided by y. What is dy from the auxiliary equation here? Dy by minus pxy. I'll take that as dy is dividing with y, means in that y is cancelled. That means here we got only qy minus dx is divided by with x. Dx is dividing by with x, here x is cancelled. That is, here we got minus px. That is qy minus px form. Okay, qy minus px form. Therefore, here after the dp by p minus dq by q divided by qy minus px. That is equal to dy by y minus dx by x divided by qy minus px. Here once you see both sides denominators are same, then I cancel the 2. That is, qy minus px is cancelled on both sides. Therefore, the remaining part here dp by p minus dq by q. That is equal to dy by y minus dx by x. Therefore, I'll take p and x one side. Okay, from that dp by p plus here minus dx by x, I'll take it on the LHS side, that is plus dx by x. That is equal to dy by y plus I'll take minus dq by q in RHS side, that is plus dq by q. That means here LHS side p dp by p plus dx by x form, and RHS side dy by y plus dq by q. Okay, now integrating on both sides. Okay, then I'll integrating on both sides, that is dp by p plus dx by x, that is equal to dq by q plus dy by y. This is above step. Now integrating on both sides. Integrating on both sides, that is dp by p means what? 1 by p integration. 1 by p integration is what? Log p. And 1 by x integration as log x. That is equal to 1 by q with respect to q integration as log q. And y 1 by y integration with respect to y, that is log y. Okay, then I'll take the constant also in terms of logarithmic. That is simply I'll take log of a square. Okay, after that, after the integration, once you observe the LHS part, which is in the form of log m plus log n. Log m plus log n, that is log of mn form. That is equal to here log a plus log b plus log c form RHS side, that is logarithmic of q y a square. Okay, both sides logarithmic cancel, then px is equal to what? Here qy a square. Px is equal to qy a square. From that I'll take p value. What is p here? Qy a square by x. P is equal to qy a square by x. Okay, from the auxiliary equation we got p value. Okay, and after the next procedure is substitute that p value in the given first equation, that is the given question. What is the given question here? That is f of xyz pq is equal to pqxy minus z square. There we can substitute p value, easily we got q. Okay, that is pqxy minus z square is equal to 0. This is the given question. There substitute p value. What is p here? Qy a square by x into qxy minus z square is equal to 0. Here x cancel, that is q square a square y square is equal to z square. From that what is q? Z square by q square is equal to z square by a square y square. From that q is equal to what? Simply z by ay. Therefore q is equal to what? z by ay. If you got q is in terms of z and a and y, now substitute that q is in the above one, that above one as p. Okay, now substitute q in, okay, substitute q in p. Substitute q in p. What is p here? P is equal to qya square by x. Okay, from that here already we know that what is q, z by ay. Z by ay x into y into a square. Here y cancel and one a cancel, therefore za by x as p. Once you see here, after substituting q in p, we got p is equal to what? Za by x. Therefore, q is equal to in terms of z and y, and p is in terms of z and x. Okay. Now substitute the p and q in the general solution. What is the formula of the general solution here? Dz is equal to pdx plus qdy. Okay, then substitute here. Dz is equal to p as za by x into dx plus z by ay into that as q as z by ay into dy. Here from these two terms, what is common? Z as common, then I'll take common z here, that is z into a by x into dx plus 1 by ay into dy. Okay, therefore that is dz by z is equal to a by x into dx plus 1 by ay into dy. Okay, 1 by ay into dy. Integrating both sides again, here integration of dz by z is equal to integration of a by x into dx plus integration of 1 by ay into dy. That is equal to 1 by z integration with respect to z as log z. That is equal to a is constant with respect to the integration with respect to x. That is a I'll take outside, and 1 by x integration is a into log x. And next here 1 by I'll take outside, and 1 by y integration with respect to y as log y. And the constant also I'll take within the logarithmic form, that is log b. Therefore, log z is equal to a into log x plus 1 by a into log y plus log b form. Okay, from that once you observe the RHS part, which is in the form of, what is the form of this again, which is in the form of log a plus log b plus log c. Okay, before writing that formula, again I'll reduce that as in the first term, which is in the form of m log n form. I'll write simply that as log of x power a plus log of y power 1 by a plus log b form. Okay, after that write down the formula of log a plus log b plus log c. That is log a into b into c. Here what is a? X power a. And what is b? Y power 1 by a. And what is c? b. That is here LHS side logarithmic of z. Both sides logarithmic cancel. Then z is equal to what? B into x power a into y power 1 by a. Okay, which is the required complete integral for the first question, that is Charpit's method. Okay, once again I'll repeat what is the procedure of the Charpit's method. First we have to assign the given question as F. After that, from the second step as, okay, let us assign the auxiliary equation. From that auxiliary equation we got either P or Q. If you got P and Q values, then we can substitute the two values in the, okay, general solution formula. What is the general solution formula? dz is equal to pdx plus qdy formula. Okay, after that integrate, after substituting p and q, next integrate. Okay, and after that we got the required solution. That is, the solution is for the first question, z is equal to b into x power a into y power 1 by a. Okay, next I'll explain one more question for the same method. That is, using Charpit's method to find the complete integral of z square into p square z square plus q square is equal to 1. Okay, same procedure. same as previous question. This as okay. Let us assume the question as f. That is f of x y z p comma q is equal to what? Z square of p square z square plus q square minus 1 is equal to 0. Okay. Next, after assigning with the f, then differentiate first with respect to x. That is, what is dou f by dou x here? Dou f by dou x is equal to dou by dou x of, first I'll multiply inside the brackets with z square, that is p square z power 4 plus q square z square minus 1. That is with respect to x. With respect to x completely, there is no x term in the given question, that is 0. Therefore, dou f by dou x is equal to how much? 0. And next, with respect to y. With respect to y, what? There is no y term in the given question. Okay, therefore, with respect to y as 0. Okay, next, with respect to z. With respect to z means, that is with respect to z, dou by dou z of p square z power 4 plus q square z square minus 1. With respect to z what? Okay, p square as constant and z power 4 differentiation as 4 into z cube p square plus z square differentiation is 2z and q square and 1 differentiation is 0. Therefore, dou f by dou z is equal to what? 4p square z cube plus 2q square z. Okay, that is the differentiation with respect to z. Next, differentiation with respect to p. Okay, that is dou f by dou p is equal to dou by dou p of, okay, p square z power 4 plus q square z square minus 1. With respect to p, the differentiation is z power 4 into 2p plus 0, 0. Therefore, 2 into p into z power 4. That is dou f by dou p. And next, differentiation with respect to q. Okay. Then with respect to q means here, the first term as 0 and q square z square differentiation as 2q into z square. Okay. 2q into z square. That is f differentiation with respect to q. Okay. Now substitute each and every value in the Charpit's equation. What is the form of the Charpit's equation here? dp by dou f by dou x plus p into dou f by dou z. This is q. That is equal to what? dq by dou f by dou y plus q into dou f by dou z. That is equal to dz by minus p into dou f by dou p minus q into dou f by dou q. That is equal to dx by minus dou f by dou p is equal to dy by minus dou f by dou q. Already we know that these all values, and substitute here. Okay, substitute here. That is dp by, after substituting all here, that is dou f by dou x as 0 and p into dou f by dou z. That is after substituting here dp by p into 4p square z cube plus 2q square z. That is the first term for the auxiliary equation. Similarly, that is equal to what? dq by, okay, dq by, substitute, what is the formula of dq here? Dou f by dou y plus q into dou f by dou z. But dou f by dou y is 0. Then substitute the next part here, q into dou f by dou z. So substituting here, we got q into 4p square z cube plus 2q square into z. Okay, that is equal to dz by, what is the formula of dz here? Minus p into dou f by dou p minus q into dou f by dou q. Then substitute here, we got minus 2p square into z power 4 minus 2q square into z square. And that is equal to what? dx by minus dou f by dou p. What is dou f by dou p here? 2p z power 4. Here in the formula minus, that is minus 2p z power 4. This is equal to, what is dy by minus dou f by dou q. After substituting that here, minus 2qz square. Okay, therefore this is the auxiliary equation. From that auxiliary equation, I'll equate any two fractions. Okay, I'll equate any two fractions. Okay, better to take here, I'll take first two fractions from the auxiliary equations. What are the two here? dp by p into 4p square z cube plus 2q square z, that is equal to dq by q into 4p square z cube plus 2q square z. If we are equating these two, easily we got either q or p value. That's why I'll take these two fractions from the auxiliary equations. Once you observe, after taking these two fractions, once you observe the denominator part as 4p square z cube plus 2q square z, and LHS side also 4p square z cube plus 2q square z. Then on both sides these two are cancelled. Then dp by p is equal to what? dq by q. Okay. From that, integrating on both sides. Integrating on both sides. That is integral of dp by p is equal to integral of dq by q. Therefore, 1 by p integration as log p and 1 by q integration as log q. And I'll take the constant term also in terms of logarithmic, that as log a. Therefore, log p plus log a is equal to what? Log q. Therefore, from that, again once you observe the LHS part, which is in the form of again log m plus log n, that as log mn form, that is log ap is equal to log q. Therefore, from that both sides logarithmic cancel. Here what is q? Q is equal to a into p. Okay, if you are equating the first two fractions from the auxiliary equation, here we got q is equal to a into p. Okay. Now substitute that q is in the, what's the next procedure? From the auxiliary equation, here we got q value. Okay, then we can substitute that value in the given question. Okay, what is the given question here? That as z square into p square z square plus a square into p square minus 1 is equal to 0. That means here question has z square into p square z square plus q square is minus 1 is equal to 0. This is the question. After substituting q, what is q here? AP, that is p square z square plus a square p square minus 1 is equal to 0. That's why I got here z square into p square z square plus a square p square minus 1 is equal to 0. From that here z square into p square z square plus a square p square is equal to what? 1. Okay, from that I'll take here what is common from the LHS side? Z square and p square is common, and the remaining z square plus a square is equal to 1. Okay, from that I'll take p square is equal to 1 by z square into z square plus a square. Okay, squaring on both sides, that is p is equal to 1 by, okay, that is z into under root z square plus a square. Therefore, what is p here? 1 by z into root of z square plus a square, that is p. And what about q here? Q is equal to, from the above last step, q is equal to ap. Q is equal to AP, but we know that P. Then substitute here, that is A into 1 by Z into root A square plus Z square. Therefore, Q is equal to what? A by Z into root A square plus Z square, and P is equal to 1 by Z into root A square plus Z square. Now we know that P and Q values, then substitute in the formula of dz is equal to pdx plus qdy form. Then dz is equal to, what is p? 1 by z into root a square plus z square plus what is q? A by z into root a square plus z square into dy. Okay, then in the next step here denominator same, then I'll take outside that is z into root of a square plus z square into dz is equal to dx plus a into dy form. Okay. Next, integrating on both sides. That is integration of z into root a square plus z square into dz is equal to integral of dx plus a into integral of dy. Once you observe LHS side, RHS side integration is easy. But what about LHS side integration, which is in the form of z into root a square plus z square into dz form? Directly, is there any possibility to write the formula? There is no formula for directly in the integration. That's why first I'll reduce that as, I'll assume here a square plus z square is equal to t square form. Okay, then I'll take a square plus z square is equal to t square, and after the differentiate with respect to z, that as a square as 0 and z square differentiation is 2z and is equal to t square differentiation is 2t into dt by dz form. From that 2z dz is equal to what? 2 into t into dt. Both side 2 cancel, that is z into dz is equal to what? T into dt. Now I'll reduce z into root a square plus z square into dz as the single term form. That's why I'm assuming these conditions here. Okay, from that now I'm substituting each and every value here. Integration of what is z into dz? Z into dz as t into dt, right? And what about root a square plus z square t square? Here I'll write that step, z into dz as t into dt, and root a square plus z square is root 2 square is equal to integration of dx plus a into integration of dy. But root 2 square means t square means, and square and root cancel, that is t into t is what? Integration of t square into dt, that is equal to, okay, integration of dx plus a into integration of dy. Then the next step, now integration of t square is what? T cube by 3. Okay, then the integration of t square as t cube by 3 is equal to integration of dx is equal to what? X plus integration of y. Integration of dy as y, a as constant. I'm taking the constant, that as plus b form. But once you observe here in the LHS side, I'm reducing that as in the terms of t. But what is t here? What is t? T is equal to from that root a square plus z square form. Therefore, substitute in place of t as a square plus z square whole power 1 by 2, or root of a square plus z square. Here already cube, that's why I'll write here a square plus z square whole power 3 by 2 form. That is equal to, here x plus ay plus b. I'll take this 3 in LHS side, that is 3 into x plus ay plus b form. Therefore, a square plus z square whole cube is equal to what? 9 into x plus ay plus b whole square. This is a complete solution for the second question. Okay. I will explain one more question from the Charpit. Find a complete integral of q is equal to 3p square. Okay, what's the procedure for that? Assume that as the given question as with respect to f, that as f of f is equal to, okay, f is equal to 3p square minus q is equal to 0. Compared to last two questions, this is simple. Okay, let us assume the given question as f and assign with the first equation. Okay, after that, what is the Charpit's equation? That is dp by, before writing the Charpit method, first I'll differentiate with respect to f as x, y, z, p, q. That is, whatever the differentiation of f with respect to x, that has 0. Okay, and next with respect to y, 0. And with respect to z, 0. And with respect to p, that is 6p, right? And with respect to q, that is minus 1. Okay, now substitute that all are in the Charpit's auxiliary equation. Now, what is the form of the auxiliary equation here? dp by dou f by dou x plus p into dou f by dou z is equal to dq by dou f by dou y plus q into dou f by dou z. That is equal to what? dz by minus p into dou f by dou p minus q into dou f by dou q. That is equal to what? dx by minus dou f by dou p. That is equal to dy by minus dou f by dou q. And the last term, it is not compulsory from the auxiliary equation. Therefore, here only the 5 terms for the auxiliary: dp, dq, dz, dx and dy. Right? Now substitute here dp by, what about dou f by dou x? 0 plus p into, what is dou f by dou z? 0. That is equal to dq by dou f by dou y plus q into dou f by dou z. Dou f by dou y is 0 plus q into dou f by dou z also 0. That is equal to dz by minus p into dou f by dou p. How much? 6p. That is minus 6p into already here p. That is minus 6p square. Minus q into dou f by dou q minus 1. That is minus of minus q as plus q. That is equal to dx by minus dou f by dou p. That is minus 6p is equal to dy by minus dou f by dou q. That is 1. Therefore, dp by 0, dq by 0, dz by minus 6p square plus q, that is equal to dx by minus 6p, and that is equal to dy by 1. Let us assume that as the second equation, or 1.111 like that. From that auxiliary equations, what are the possibility to solve p and q values from the auxiliary? Then we can take any two fractions. Okay, here the possibilities are possibilities from the auxiliary equation. I'm taking first two terms. From the two terms only, maybe I got either p or q. That's why equating the two, that is dp by 0 and that is equal to dq by 0. I'll take the first fraction, not for 2. I'll take only 1. Why? Because from that only we got directly p value. Okay, that means dp is equal to 0 form. So that integrating on both sides, that is p is equal to what? A. Let us take that as the third equation. Okay, from the auxiliary equation, from the first fraction only I got p value, that is equal to p is equal to a. Then substitute that p value in the first equation. What is the first equation? That is the given question. Okay, then substitute that p value in the first equation. Then the first equation form is q f is equal to q minus 3p square, right? F is equal to q minus 3p square. There substitute p value is equal to 0. That is q minus 3p square is equal to 0. Already p is equal to a, that is a square. Therefore, q is equal to what? 3a square. Okay, from the auxiliary equation, we got p value. After substituting p value in the first equation, we got q value. Therefore, p is equal to a and q is equal to 3a square. Then substitute that 2 are in the formula of dz is equal to pdx plus q dy. Therefore, dz equal to a dx plus 3a square into dy. Okay, then integrating on both sides, that z is equal to what? Z is equal to ax. Okay, how to integrate? Integration of dz is equal to integral of a into dx plus integral of 3a square into dy. That is integral dz means z and a into integration of dx as x plus 3a square into integration of dy as y plus constant b. Okay, therefore what is the complete integral for the third question? Z is equal to ax plus 3a square y plus b. This is the solution for the third question. These are the three questions from the Charpit's method, very important method. Okay, next class we will discuss some other related questions on next method. Okay, thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.